This is an extension to question 10 on the test, so I'm gonna talk a little bit more about this equation right here, which is r cosine open parentheses theta minus 2 pi over 5 close parentheses equals 2. So we know that this equation takes the general form of this, which is r cosine open parentheses theta minus alpha close parentheses equals d, where d comma alpha is the foot of the perpendicular line segment drawn from the origin. And over here I wrote the equation from the test. So in this video I'm going to show the different ways to turn this polar equation into rectangular form. So the first way to do it is to use the trig identity. In this case we have cosine A minus B, so this is just cosine A cosine B plus sine A sine B, and this is what I did over here, and then I multiply r to each term. So in this case I have r cosine theta, and I know that this is just x, and in here I have r sine theta, and this is just y. After that I turn this equation into the form of y equals mx plus b, and this is what I have. The second way to turn the equation into rectangular form is to use the x and the y intercept. To find the x-intercept, I substituted in 0 for theta, and I got that r is equal to 6.5. And to find the y-intercept, I substituted in pi over 2 for theta, and I got that r is equal to 2.1. So I have these 2 points on the line, and I turn these 2 points into rectangular form over here. So now there are two things you can do. I think the easier method is to use this equation, because since you already know the x and the y intercept, you can just substitute in 6.5 for a, because this is the x intercept, and then for b you can substitute in the y intercept, which is just 2.1. so this is the equation. And another way to do it is, since you are given 2 points, you can use the slope formula to find the slope, and then since you already know the y-intercept, which is 2.1, you can then substitute in these two values into y equals mx plus b, and these two equations should be exactly the same. And just to show that they are the same, I type these two equations into the graphing calculator, and I'm gonna hit graph. So this is the first equation, and then the second equation, it's gonna overlap the first equation, because since they're the same, then it makes sense that they overlap. And also just to show how the equation looks like in polar form, I also so I also have it here, and when I enter graph, it should be exactly the same as the graph that we saw previously. So these are the ways to turn a polar equation into rectangular form.